My name is Dr. Patricia Rankin. I am the chair and a professor in the Department of Physics at Arizona State University. My dissertation research focused on charm photo production, and my work now focuses on science policy. I have had a fairly non-standard career. So I started off as a very traditional experimental particle physicist. And one of the things I am very proud of is working on measuring the mass of the Z0 particle at SLAC. This was actually something where we had to figure out how to do it with a minimal amount of data because the accelerator was not working very well. So I actually studied how much information you can get in particle physics from not observing a particle and mapped out an optimal trajectory for the strategy of scanning across the peak so that we would get as much information as possible, as fast as possible to figure out where the mass peak was, which allowed us to get a very important result before a competing experiment did. So that's my very traditional particle physics success. And even that is not very traditional particle physics because I was figuring things out by not seeing a particle rather than seeing a particle. Less traditionally, I spent a couple of years at the National Science Foundation working on particle physics funding. And I worked with the State Department and with the NSF leadership on setting up the agreement so that American researchers could work at the Large Hadron Collider as well as European researchers. So that was a mix of particle physics and politics and working with the State Department and working with people in ways that I wasn't used to working with people previously. And it was just interesting to me to see how things worked from that side. And then my final success that I'm going to mention was I had a large grant at the University of Colorado to work on getting more women into leadership positions in science and engineering. And that was when I really started paying attention, not just to the issues faced by women in science, but also to the research on inclusion. So I'm really happy about the fact that I've had the opportunity to mentor some women so that they had much better experiences than they might have had if they had not had somebody to go to give them advice on how to navigate some difficult situations. I enjoyed it because it was a chance to pay it forward. And I was also able to teach people about negotiation, which honestly was a skill I didn't have when I took my first university job. I didn't realize that I could significantly have increased my first year salary as a faculty member if I had negotiated it. So I have made it somewhat of a passion project of mine to make sure that succeeding generations of people do not fail to know the importance of negotiation. I was actually struggling to answer this question when I was reading through the questions before you asked me, because I think part of this is attitude. So for me, because I was in particle physics, there were certainly times when I looked for particle signals that I was hoping to find that I didn't. However, I think it's a frame of mind when you start to realize that not finding those particles tells you something too. In fact, if you remember back to my success, right, I'm talking about what I learned from not observing Z0 particles. So in some ways, that's the theme of my research. But sometimes you have to do the negative searches in order to figure out how to do a search that's either better or why it's a dead end. And to me, that's the nature of being in a frontier field. I think the difference in being in grad school and being an undergrad in physics is generally that as an undergrad in physics, you're doing an experiment where you sort of know the result you expect. When you do the Millikan oil drop experiments, you're not expecting to find fractional charge. When you're a grad student, if you're being a successful grad student, you're almost bound occasionally to either hope that you're going to find something that isn't there, or to try a technique that doesn't work quite the way you expected it to do, or to try something that you think will have a different result because you don't have all the information. So for me, one of the things you have to learn as a grad student is that you learn something from the things that don't go right as much as you do from the things that work. If we only ever found out what we're expecting in science, we're really not being good scientists, because science is all about discovering where science goes wrong and how you fix it and how you make it better and how it can be more interesting. This is really the Picard maxim from Star Trek: The Next Generation. You may not be fans of that. I go back to the original series of Star Trek and have loved it ever since. But the Picard maxim is that sometimes you can do everything right and still lose. And that's not a failure, it's life. So try and focus on the fact that things not going the way you intend them to go doesn't necessarily mean you screwed up. It can just mean that's the way it is. I started my graduate career looking for something called baryonium, which is an exotic state of matter. I didn't find any, but there was a point where I thought I had found some. But I was fairly junior and I really didn't understand the statistics of what I was doing well enough at that point to know that if you look at enough data sets long enough and make enough selection criteria on them, you're almost bound to find something that looks like it's a signal. But if you then go back and do a cross-check by looking at another data set with the same set of cuts, you don't see the same signal, which tells you it was a fluctuation, not a genuine particle. And that's disappointing in the sense that it would have been a Nobel Prize in all likelihood if I'd found it. But it's not disappointing in the sense of, well, that was the end of my career. You go on and you do the next particle search better, differently, you've learned your lesson. And so for me, it was really no big deal not to find what I was looking for in particle physics, as long as I'd actually done a good analysis job, made sensible selection criteria. I came into physics with some self-confidence, and that certainly helped me get through some of the times where I might have thought, boy, this was maybe not the best choice I could have made. So for me, I think you really need to realize that as a grad student, you're almost bound to be disappointed at one time or another or multiple times. And for me, the failure is not looking at that and figuring out what you did wrong or what you could do better or what you could do differently. So I'm just going to admit to this. There was a point when I was writing my thesis where I basically had to bribe myself with the promise of chocolates if I would write another few pages, which was possibly not the healthiest of coping mechanisms I could come up with. But at a certain point, you've eaten enough chocolates and you need to figure out better ways of managing. Whether it's switching to getting some fruit, or whether it's realizing that what you really need to do is to take a break. So for me, my real coping skill is that you've really got to look at moving forward at a certain point. You've got to view things like writing your thesis as something you do to make it through to the next stage. While this probably isn't something that grad students necessarily going to believe, writing your thesis is not the most important part of your career as a scientist. It's something that at a certain point you do to get it done so you can actually move on to the next thing. So focusing on your thesis as if you're just suddenly going to feel miraculously better when you finished it, what you're actually going to figure is probably a big sense of, boy, now what? Which I think is true actually of a lot of things that you succeed to do. You succeed and you focused on it for years, and then you've got to figure out what to do next. So focusing on what to do next, I think, is important. There's a lot to be said for your best support network being your peers. I think people feel safer talking to their peers about things that went wrong rather than people who are in sort of leadership positions with respect to them. If you talk to your peers, you're going to see less judgment because they're all going through the same things. I think you also want to spend some time with people who don't think what you're doing is all that important, because that helps you figure out how to normalize some of the things that are going on. And also just take breaks and learn about something totally different. I will tell you that one of my coping mechanisms now is to read mystery stories. And if somebody's particularly annoyed me, I actually imagine them as the victim, and somehow that is a way of compartmentalizing the stress. It almost seems automatic, because in particle physics, you have to expect not to always find the particle you're looking for. You hope to find it, but you may not find it. So not blaming yourself is important. If something is not there in the data, it's not there in the data. You can't magically make it appear. In fact, you shouldn't even try to magically make it appear. All you can do is say, look, okay, I did not find this. What might I find instead? What is it telling me that I didn't find this? Is there a theory that might guide me to look in a slightly different way? When I was in high school, I certainly had some really spectacular failed experiments that were my fault for not following the instructions correctly. Fortunately, I always had people around that made sure that those mistakes were never actually going to hurt me. And as I say, I am tremendously fortunate that people allowed me to make the stupid mistakes that I was going to learn from, but not the dangerous mistakes that were probably going to bring my career to a precipitous end. In many ways, having people that will let you make mistakes and learn from your mistakes is one of the most useful things that you can have. And getting used to the fact that you're going to fail and it's no bad thing and it's no reflection on you is a great thing to understand. So the fact you fail doesn't mean you're going to continue to fail. And if you do, it's really the way the universe is set up. So if you screw up and you mix two chemicals together and you get the proportions wrong, you can fix it. It's not the end of the world. My first piece of advice is that if you're starting to struggle, reach out. Do not struggle alone. Talk to somebody, talk to your peer network, talk to somebody who is in student advising. But don't think that you're the only person who's having a problem, and don't think that if you're having a problem, people don't want to help. My second piece of advice is that if problems are starting to develop, perhaps between you and your advisor, they are not miraculously going to resolve themselves. In my experience, problems do not mysteriously or miraculously go away. So for example, if you're having issues with your advisor, the sooner you can get advice about how to change that situation, the better. More generally, there are times when you're getting particularly stuck, and there are going to be times when you're getting particularly stuck. And the most helpful thing you can do is to actually step away. Go for a hike in the mountain. Go for a walk around the lake. If it's 100 degrees outside and you can't do that, maybe just go find somewhere where you can sit and read a book. At a certain point, if you're stuck sitting there, either looking at a piece of paper expecting words to miraculously appear, or to figure out what is going wrong with your experiment, it's not going to help unstick you. Stepping away from it, doing something totally different and something enjoyable, that's going to be what gets you through it. And that's going to be what keeps you sane and what keeps you healthy and what makes you enthusiastic about studying your science. As a particle physicist, I think it's somewhat easier to do this because as an experimentalist, you work in large groups. And I know that's not true in all sciences. But in particle physics, you tend naturally to have the other graduate students in that area on that experiment as a support group that you don't have when you're working on smaller experiments. So there may be fewer grad students around you. You may not be able to find the grad students you really like in your near field. So asking for the grad school or the department to give you ways to get together with broader groups of grad students, I think is important, because you've got to start making those networks. You've got to connect to other people, and you've got to know when you're getting so stressed it's not helpful to continue, and other people will tell you to step away even if you can't do that yourself. So thank you for watching Fail-Safe Science. My name is Patricia, and I really hope I've given you faith that you can fail and still be successful. Thank you.